Hi girls, I just want to put together a quick video to help you with your work today while I am not with you, your work on writing half equations. We started to look at this on Monday, but we didn't get going through all of the worked examples, so I just want to go through the rest of the worked examples to try and build up your confidence in that and make sure that you know what you're doing. So we're using oxidation states to balance or write half equations. And what you need to remember is that oxidation involves an increase in oxidation state and reduction involves a decrease in oxidation state. This is just on page 15. We're not going to go through all of page 15 because we did that on Monday. But in equations, whether that's half equations or ionic equations or full equations, oxidation states must be balanced, just as the number of electrons must be balanced in half equations. So this is more important when we put two half equations together, because what we have seen is that as one substance loses electrons, the other substance gains electrons, or thinking of it in terms of oxidation state. As one element increases in oxidation state, the other element decreases in oxidation state, and that needs to be by the same number, because ultimately that comes from the loss or gain of electrons, which must be balanced. But we're going to focus in this video just at writing and balancing half equations using oxidation state. So let's go over to page 16. And I know we've done worked example 1 already, but let's go through that again, or you can skip by to worked example 2 if you're confident. But this is really just like writing half equations, which we met earlier on in the topic. But these examples can involve the likes of oxygen and hydrogen, and so we need a couple of extra steps to balance those as well. But if you look back to your general steps of writing half equations on page 4, then this is a similar format, but there's a couple of extra steps. So if you were asked to write a half equation for the conversion of the manganate ion into the manganese ion, you need to start essentially, before even we get into step 1, as we would have done before, writing the formula of our reactant into our product. So a reactant is the manganate ion, MnO4 minus, and that's being reduced to Mn2 plus. So that's your reactant to product, which is the start of this half equation. So step number 1, and you can continue to follow these steps as you do some examples, particularly in your early stages of doing this type of question. The first step is to balance all of the atoms except hydrogen and oxygen. So the one that we're referring to here is manganese in this example. And if you count the number of atoms, you can see that there's one on the left and one on the right. So nothing needs done here. So you can put a line through that, or you can rewrite that reactant to product if you wish. The manganese is already balanced. You could put in there. Okay, and you won't necessarily write this out each and every time, but to have a few worked examples in your notes would be good. The next step is to balance oxygen with waters, and this will make more sense when we kind of put two half equations together as to why water is produced. But you can see that we've got oxygen on the left and no oxygen on the right, and that just can't happen. We can't just have oxygen disappearing. What that will form when it's combined with another half equation is it will form water. So what we do is we say, okay, well, we've got 4 oxygens on the left. So we have 4 oxygen atoms on the left, and that means that we need 4 waters on the right-hand side, because each water molecule is only providing me with 1 oxygen. So our half equation, as we build it up, will become MnO4 minus going to Mn2 plus 4 H2O, so that's what we've added in at this stage, so I'm just doing that in a different colour. But now we've introduced another atom into our equation, which we can't account for on the left-hand side now. So you can see that we now have a total of 8 hydrogen atoms on the right, and that's because we've got 4 waters, and there's 2 waters in each, 2 hydrogens in each water. So if we have 8 hydrogen atoms on the right hand side, we need 8 on the left hand side, and we're balancing that with H plus, so that's only providing 1 hydrogen atom per hydrogen ion, so that means we need 8 H plus on the left hand side. So our equation now becomes MnO4 minus plus 8H plus going to Mn2 plus the 4 waters that we added in at the previous stage. Okay, next step then is to balance the oxidation state with electrons. Now, in general, in these half equations, the oxidation state of oxygen won't change, it'll just be -2. The oxidation state of hydrogen won't change, it will be +1. So you're looking at your other element, and in this case, it is manganese. So what we need to do first of all is work out our oxidation state on the left hand side and on the right hand side. So let's do it on the left hand side first of all. If I just drag the screen across a wee bit, you can fit this in at the side if you wish. You need to actually work out your oxidation state. So manganese is essentially our X. Oxygen, remember its oxidation state is -2, and we've got 4 of those, so that's going to be -8. And to solve for X, we need to do X minus 8 equals -1, because that's the charge on the ion. So this is not a neutral compound, this is a molecular ion. So rearranging that to solve for X, and we bring the -8 over to the other side and it becomes +8. So -1 + 8 is +7. So the oxidation state of our manganese on the left-hand side is +7. So you could put that maybe in a wee circle beside it. And then on the right-hand side, you can see that it's just a simple ion of manganese. It's Mn2+. And so one of our rules states that the oxidation state of a simple ion is equal to its charge. So that's going to be +2 in this case. So we're going from +7 to +2. So if we think back to what that means in terms of our change in oxidation state, we're going from +7 to +2. So that's a decrease in oxidation state by 5, and that makes this reduction. Then you're going back to what we talked about previously in terms of, well, reduction means that the electrons are on the left hand side, and if our oxidation state is decreasing by 5, we need 5 electrons on the left hand side. So I'll squeeze that in there, okay? So step number 4 is finally going to be then MnO4 minus plus 8H plus our 5 electrons, giving you Mn2 plus 4H2O, and this is reduction, because the electrons are on the left hand side. So those 5 electrons are to account for the fact my oxidation state has decreased by 5, and they're going on the left hand side. What you can do at this stage is you can get your total charge on each side of the equation and double check that it's balanced in terms of charge, and that's a way to check that you have done this correctly. So if we look at the charge on the left hand side, it's minus. So -1 essentially, plus 8 from our 8H plus minus 5, which gives us +2. And on the right hand side, our only charge particle is Mn2 plus, and that is a charge of +2 as well. So the charges are balanced, which gives us an indication that we have done this correctly. Obviously, you may have made mistakes previously, but at least we need to check at the end that our charge is balanced. Once you have done step 3, you can do this by just simply counting up your charge on either side and choosing which side needs to go down in charge and add your electrons to the appropriate size, but we're trying to get into this habit of looking at the change in oxidation state and what that then means for the number of electrons that we need to put on either side of our equation. So that's a worked example 1. Let's have a wee look at worked example 2 now. So here we're writing a half equation for the dichromate ion being reduced to chromium. So that is Cr2O7 2- being reduced to chromium Cr3+. So writing your reactant to product first of all. And then step 1 in balancing the half equation is to balance all atoms except your hydrogen and your oxygen. So you can see in this equation, we have got 7 oxygens on the left-hand side, and so we need 7 waters on the right-hand side to balance the oxygens to get me 7 oxygen atoms on the right-hand side. So that becomes Cr2O7 2- becoming 2Cr3+ plus 7 H2O on the right hand side. That's our oxygen now balanced, but we have now introduced hydrogen into our equation. And so we can see, if you count the total hydrogens on the right hand side, we have 14 hydrogens on the right hand side. And so that means we need 14H plus on the left hand side. So let's add that in now. So we have Cr2O7, 2 minus, plus 14H plus, giving us 2Cr3 plus 7H2O as we had before. Okay, and then step number 4 is to balance the oxidation state with electrons. Now we need to be careful with this one because we have 2 chromium atoms in our equation, so we'll think about that carefully in a second. So again, we need to work out the oxidation state of chromium on the left hand side. So that's Cr2O7, 2 minus. So we've got 2X here from our 2 chromiums. And we have 7 oxygens, so that's going to be 7 times minus 2, which is minus 14. And that's all going to equal a charge of minus 2. So 2x minus 14 equals minus 2. Rearrange for x, that becomes 2x equals plus 12, x equals plus 6. So the oxidation state of each chromium atom on the left-hand side is plus 6. And on the right-hand side, you can see that it's just a simple ion. Its oxidation state is plus 3. You ignore the balancing number here. You want to know what is the oxidation state of the individual atom within the formula. You don't include the balancing number because that's to do with the overall reaction. It's not to do with the individual oxidation state as such. So let's now have a think about what has happened in terms of the change of our oxidation state. We can see that there is a decrease in oxidation state by 3. Okay, we're going from plus 6 to plus 3. So that's a decrease in oxidation state by 3. But however, there are 2 chromium atoms. There are 2 chromium atoms and each of them is going from plus 6 to plus 3. Okay, so you could write there each needs 3 electrons. Okay, so here again we have got a reduction because it's a decrease in oxidation state. So each needs 3 electrons. So that is a total of 2 times 3 equals 6 electrons needed on the left hand side because this is a reduction. Okay, decrease in oxidation state tells us that this is reduction. Therefore, the electrons are going on the left hand side. There's a decrease by 3, but that's for each chromium atom. So it's a total of 6 electrons needed on the left hand side. Let's write those in and then we'll see what that does to the charge and show that that is now balanced in terms of the charge. Ultimately, this step is about balancing the charge. So if you find it easier to count up your charge and balance with electrons that way, that is okay. Sometimes that avoids making the mistakes of forgetting that there's 2 chromium atoms. But it's good to look at it both ways to see which you prefer. So that ends up being our final equation, Cr2O7, 2 minus, plus 14H plus 6E minus, giving us 2Cr3 plus 7H2O. Again, if we're to look at the charge on either side of the equation, if we look on the left-hand side, we've got minus 2 from our dichromate ion, plus 14 from our H plus, minus 6 from our electrons, and that gives us a charge of plus 6 on the left hand side, and on the right hand side we've got 2 times by plus 3, which is plus 6, so you can see the charge is balanced. So if you had done this and you'd forgotten that there was 2 chromium atoms and say for example just added 3 electrons on the left hand side, doing your final check at the end, is the charge balance, you would have seen, okay, no, the charge isn't balanced, what have I done wrong? So that's important to check. But as I said, if you'd prefer just to, after step number 3, count up the charge on either side of the equation and work out how many electrons you need and which side you need to add them onto, like we would have done with the previous half equations, that is also okay. Okay, and finally, let's look at worked example 3 and then over to you for some practice of this. So here we have the oxidation of sulfur dioxide into sulfate. So again, write your wee reactant into product. So sulfur dioxide into sulfate, SO4 2 minus. Next stage, balance all the atoms except hydrogen and oxygen. In this case, that is sulfur, so we don't need to do anything because there's one on the left, one on the right. So sulfur already balanced. Okay, so we don't need to do anything at this stage. Then we need to balance our oxygens with waters. We need to be careful here because we have, if we look carefully at our equation, we have 2 oxygens on the left-hand side. We have 4 on the right-hand side. So we do actually have oxygen on both sides, but they're not balanced. And we can't just multiply our sulfur dioxide by 2 because that would then make the sulfur not balanced, and then we could put a 2 in front of the sulfate and we would just keep going round and round in circles. So always balance the oxygen by adding waters. So we need more oxygen on the left-hand side, so we need to add 2 waters to the left-hand side. So be careful about that one. There's already oxygen there, so you're thinking, how much more oxygen do I need? So that then becomes SO2 plus 2H2O. And you can see now my oxygens will be balanced, and that becomes SO4 2 minus. So you can count your oxygens up to check. You've got 4 on the left and now 4 on the right. Next step is to balance the hydrogens with H plus ions. So if you have a wee look at your left hand side, you've got 4 hydrogen atoms on the left hand side. So that means we need to add 4 H plus to the right hand side. Okay, so that becomes SO2 plus 2H2O, haven't changed the left hand side, giving you SO4 2 minus plus 4H plus. Finally then, let's balance the oxidation state with electrons, and we will look this time at oxidation state again. Again, you can balance at this stage by counting up your charge on either side of the equation and working out which side to add your electrons to. But let's have a wee look at the oxidation state of sulfur. So in SO2, first of all, if we write off to the side, SO2, S is your X. Oxygen is minus 2 times by 2, which is minus 4. So X minus 4 is equal to 0 because this is a neutral compound. So X is going to equal plus 4. So the oxidation state of sulfur on the left-hand side is plus 4. And then let's have a look on the right-hand side. So we have got SO4 2 minus this time. So the sulfur is our X. Oxygen is minus 2 times by 4, which is minus 8, and that's all going to equal minus 2. So X minus 8 equals minus 2. Rearrange that equation, you get X equals plus 6. So the oxidation state of sulfur on your left-hand side, if I just write it underneath, or you can write it to the right-hand side, is plus 6. So again, let's think what's happening in terms of the oxidation state. It's changing from plus 4 to plus 6. So there's actually an increase in oxidation state this time. Increase in oxidation state by 2. So that's important. Because the oxidation state is increasing, that makes this oxidation. So that means the electrons need to go on the right-hand side this time. And if it needs to increase by 2, then we need to put 2 electrons on the right-hand side. There's only one sulfur atom here, so we only need 2 electrons, but that's a good thing to check. Am I doing this for 1 atom? Am I doing it for 2? Because that could change the number of electrons that you need. You might need to multiply that up. So let's rewrite our final equation with those 2 electrons in. SO2 plus 2H2O, giving you SO4 2 minus plus 4H plus 2 electrons. And we can see because the electrons are on the right hand side, this is an oxidation reaction. So again, we could check have I added the correct number of electrons? By checking the charge. So the charge in the left hand side at the minute is 0 because there are no charged particles here. On the right hand side it's -2 from your sulfate, +4 from your H+ ions, -2 from your electrons, which equals 0. So the charge balance, so that gives us a clue that we have done this correctly, or we certainly balanced the charge correctly. So hopefully that's helpful, and hopefully you understand the different steps. Do just go through the different steps each time. You don't need to write out every step each time, but do leave yourself enough space on either side of the equation to add your waters, add your H+ ions. Make sure you do it in the correct order, because if you balance the charge first and then add in H+ ions, it won't work, and that will affect the charge. So what you need to do now is go to page 26 and page 27, and I want you to complete these pages, which is just some practice of half equations. So let me take you to that now very briefly. So if you have a wee look at page 26, first of all, you are asked to write half equations for the following processes. That's question 1, and then question 2 and 3 are on page 27 as well. So answer all of these questions on page 26 and 27. Just to highlight steps or numbers 1 to 3, these are your kind of simple type. So you can follow the steps on page 4, I think it is. These examples won't involve oxygen and hydrogen, so you don't need to go through that step of balancing oxygens with water, balancing hydrogens with H+. You can follow that step, those steps as well, it's fine. It's just that you don't have any oxygen to balance, so don't add in any waters or don't add in any H+ ions. But from part 4 onwards, you will need to use those rules that we've just talked about. And the questions go on to page 27 as well. So again, if you could have a wee go at doing those, there's some space there for you to fill in your answers and do your working out. Again, just kind of build the equation as you go, adding waters, adding H+ ions, and then adding electrons. And if you have a wee go at that now, and anything you don't get finished of page 26 and 27, if you can finish off in study or at home, and then we will check through these in our next lesson, which will be after half term. Okay, hope you get on okay with those. If you have any questions or are struggling with them, please just put a message on Teams or send me a wee email.